So let's take a look now at a diverging mirror or a convex mirror. And of course, what we'll find with this is that we still have a focal point. And the thing with the focal point and the center of curvature is that they are now behind the mirror. We'd be standing over on this side looking into the mirror, and of course the center of curvature is behind the mirror and the focal point. There are actually two focal points. There's also a focal point that could be drawn here, and we will sometimes use that in some of the diagrams we might have to draw. Anyways, first ray, again, drawn parallel to the principal axis from the tip of the object to the mirror. The reflected ray appears to diverge from the focal point. And so it appears to diverge as if it came from the focal point. And of course, the second ray, it goes towards the focal point, which is behind the mirror, and then of course it's reflected parallel to the principal axis, and of course we can extend a line there. These two lines, the first line that we drew through the focal point, and this one will actually tell us where the image is. The third line just confirms that. The third line would be drawn from the tip of the object through the center of curvature. Where those three lines converge, right here, that's where our image will be. And of course you can see in this case that the image is erect or right side up, and because it's right side up, it's virtual. And of course you can also see from the ray diagram that it's smaller than the object, and so it's diminished. Alright, so the object is upright, smaller, and of course it's virtual. Now here's the mirror equation for both the convex and the concave, and of course 1 over the focal point is equal to 1 over the distance to the object plus 1 over the distance to the image. It's very important that you make sure that you understand the sign conventions for the mirrors. All right, for concave, DO and DI. DO is always positive, F is always positive, but DI may or may not be positive. If it's in front of the mirror, then it's going to be positive. If it's behind the mirror or a virtual image, then it's going to be negative, and that's how you can tell. For diverging mirrors, the focal point is actually negative. All right, so if you have a diverging mirror like the kind you would see in a convenience store or on the right side of your passenger door, that's a negative focal point because the focal point is behind the mirror. DO is still positive. Now generally DI you'll find is, and of course here are some of your conventions. A real focus point is positive F. A real image is positive DI. A virtual focus point, such as on a diverging mirror, a virtual focus point is going to be negative F. Virtual images are negative, and of course if it's above the principal axis it's positive. If it's inverted, then it's negative. Here's first of all the magnification equation. The magnification is simply a ratio of the height of the image divided by the height of the object, or the displacement of the image from the mirror divided by the displacement of the object from the mirror. All right, if your object is further away, then it will be larger as well. A direct relationship there.